Magandang malusog na Johnny-Ann. Good day everyone, it's me Teacher Rena. This video will simply help you answering your module about pattern and sequence. And these are the objectives that will guide us along the way. To solve and generate patterns. To solve sequence using explicit form. To solve sequence using recursive form. In your previous years, patterns is perceived by simply looking at the similarities of objects or things. Patterns are repetitive sequences that can be found in nature, shapes, events, sets of numbers, and almost everywhere you care to look. For example, seeds in a sunflower, tile, the number sequence 2, 4, 6, and so on. Patterns are useful to predict what came before or what comes after a set of numbers that are arranged in a particular order. Example: 5, 8, 11, 14, 17. A sequence is a succession of numbers in a specific orders. Each number in a sequence is called term. The terms that are formed according to some fixed rule or property. Example: find the missing terms in a given sequence. 8, blank, 16, blank, 24, 28, 32. Find the pattern, look closely at 24, 28, 32. Each term in the number sequence is formed by adding 4 to the preceding number. So, the missing terms are 8 plus 4 is equal to 12 and 16 plus 4 is equal to 20. Therefore, the sequence is 8, 12, 16, 20, 24, 28, 32. Here are ways of expressing sequences. A sequence may appear as a list of finite or infinite. 1, 5, 9, 13, 17 is an example of finite sequence. 1, 5, 9, 13, 17, 21, and so on is an illustration of infinite sequence. Listing makes it easy to see any pattern in a sequence. It will be the only option if the sequence have no pattern. A sequence may appear as explicit form or recursive form. Explicit form of a sequence can be expressed in a form which a preceding term is not necessary to find the succeeding term. This explicit form can be used to find the term of the sequence by determining its position.
For example, write the explicit form for the sequence 5, 8, 11, 14, and so on, then determine the... Let us consider the sequence given. 5 represent the first term as a sub 1. 8 represent the second term as a sub 2. 11 represent the third term as a sub 3. 14 represent the fourth term as a sub 4. It is customary to use the notation a sub n to designate the n term. The three dots indicates that the sequence continues beyond 14, as seen by the ellipsis. Now, let us find the common difference of the sequence. Common difference is the difference between the consecutive terms. Now, we have 8 minus 5, that is 3, 11 minus 8, 3, 14 minus 11, that is 3. So our common difference of the sequence is 3. After getting the common difference, let us try to find the term before 5. How could we do it? It's just very simple. You just subtract your a sub 1 to your common difference, which is 3. So we have 5 minus 3, that is 2. Very good. We can get any term in the sequence by taking the common difference, 3, multiply the n term, added by 2. So this given is the formula in getting the explicit form. Your a sub 1 is equal to 3. You just substitute your n, which is 1 plus 2. That is equal to 5. Very good. How about a sub 2? Copy 3, then substitute your n, which is 2. Copy 2 is equal to 8. Very good. How about a sub 3? A sub 3 is equal to 3. Substitute by your n, which is 3, plus 2, that is equal to 11. That is correct. A sub 4. Let us get a sub 4 if it is 14. 3 multiply by 4 plus 2, that is 14. Very good. So your a sub n is equal to 3n plus 2 is the explicit form for this given sequence. Now let us try to find the next two terms. By using this explicit formula, a sub n is equal to 3n plus 2. Your a sub 5 is equal to 3. Substitute your n, which is 5 plus 2. That is equal to 17. Very good. How about a sub 6? A sub 6 is equal to 3 times 6 plus 2 is equal to 20. Very good. Therefore, the given sequence is 5, 8, 11, 14, 17, and 20.
Recursive form of a sequence. It can be expressed if the first term and a recursive formula are given. A recursive formula is an expression used to determine the nth term of the sequence by using the terms that precedes it.
Now let's proceed to recursive form of a sequence. A recursive formula designates the starting term a sub 1 and the nth term of the sequence a sub n as an expression containing the previous term, or a sub n minus 1, which is the term before it. Example: write the recursive form for the sequence 5, 9, 13, 17, and so on, then determine the next two terms. Consider the sequence below. Your first term is 5, and that is your a sub 1. Your 9, that is your a sub 2. 13 is the third term, serve as your a sub 3. 17, that is a sub 4, and so on, represent by a sub n, or your n term. Now let us find the common difference by simply subtracting the preceding term to its previous term. So we have 9 minus 5, that is 4. 13 minus 9, that is 4. 17 minus 13 is equal to 4. So the common difference of the sequence is 4. Very good. What is your first term again? Okay, 5, and the common difference is 4. So we have here the solution. To determine the nth term of the sequence, we will be using the term that precedes it. So what is the term that precedes a sub 1? That is a sub 2. So we will be using a sub 2 to look for the preceding term. So a sub 1 plus, what is your common difference? Very good, 4. And that is, you just substitute the given value of your a sub 1. So a sub 1 is equal to 5 plus your common difference, which is 4. 5 plus 4, we got 9. So as you can see, our a sub 2 is, yes, correct, that is 9. How about a sub 3? So what is the term that precedes before a sub 3? Very good. That is a sub 2. So we have a sub 2 plus 4. That is a sub 2. Substitute your a sub 2. That is 9 plus 4. 9 plus 4. That is equal to 13. Very good. Next, how about a sub 4? What is the term that precedes before a sub 4? Very good. That is a sub 3 plus 4. That is a sub 4 is equal to 13 plus 14. That is 17. So as you can see, with our given sequence, your a sub 4 is 17. So this given pattern is what we call recursive form of a sequence, wherein your first term and your recursive formula are given. We can have the pattern of a sub n is equal to a sub n minus 1, which is, this is what we call the previous term of the preceding term, plus the common difference, which is the difference of the consecutive terms. The recursive formula can be written as a sub n is equal to a sub n minus 1 plus 4. So this is our recursive formula given this sequence. So the next two terms are, what is the next two terms? So we will be using this formula again. We have a sub 5 is equal to a sub 4 plus 4. That is equal to 21. So 17 plus 4, that is 21. So that is your a sub 5. And how about your a sub 6? So by simply 21 plus 4, that is 25. Very good. So that is a recursive. Have you learned something new today? Very good. Let's see if you had understood our lesson. Kindly open your SLM and turn it on page 13. Answer items 1 to 10. Well done! Congratulations, learners! Quarter 1, Module 1 completed. See you on our next video about Module 2. Keep safe and stay healthy. Magandang malisog na Jani Ang.